Welcome, mathematicians. Let's warm up our brain with a little do now. Please use a straight edge. So if you have a ruler, great. Otherwise, you can use the edge of your math journal or a folder and follow the directions. We're throwing back to some of our geometry from last unit with rays and line segments and lines and angles. So warm up your brain, try these out, and then play back the video when you're ready to see the answer. Okay, yours might look slightly different from mine because there's more than one right way to draw these, but let's focus on some of the keywords. So in one, you needed to make sure that you were drawing rays, so they have a end point in one side and an arrow showing they go on forever in that direction on the other side. And you also need to make sure they were parallel, which meant they go in the same direction, so they're never going to be touching. One common mistake is sometimes when people draw their rays, they forget to draw a second point, right? So I had C was my end point where I have no arrow, but then D, I want to make sure I draw an arrow in the direction of D, but point D, I need to actually put it somewhere on my ray, not right on top of my arrow. So I had a point D, and then it's going on forever in the direction of point D. Okay, let's look at number 2. You needed to have a line segment and a line. So we remember that our line is going to have arrows on both ends. That one was called ND. And then our line segment was line segment BC. I may have made this joke before, but I was kind of thinking Boston College intersecting with Notre Dame. I know there's some rivalry among those schools. So, and then intersecting meant that they were going to hit at exactly one point. So make sure you showed that in some way. And finally, name this angle in 2 ways. So I needed to draw my angle symbol. And this symbol in math notation always means angle. Even if it were an obtuse angle or a right angle, I'd still draw this symbol to show that it's calling us angle EDF. Another way to name it is angle FDE. But notice in both cases, D had to be in the middle because D, do you remember what we call that point? D was our vertex. So to name the angle correctly, we need to make sure the vertex was in the middle. Great. Today, we're going to move on in our geometry study to a new type of shape. So take a look at these pictures. What do all of these shapes have in common? Think it in your head. Were you thinking they all are 4-sided polygons? Remember, polygon meaning it's a closed shape made up of line segments, and they all had 4 sides. Yesterday we talked about triangles with 3 sides. Today we're talking about shapes with 4 sides. Do you know what a 4-sided polygon is called? They are quadrilaterals. Everybody say that with enthusiasm. Quadrilaterals. Great, because we have this prefix quad here, and quad means 4. And actually lateral means side. So this is literally saying they have 4 sides. There are certain types of quadrilaterals that we want you to be able to recognize and name some properties of. So in your notes, you're going to write the special term, the picture, and then I'm going to tell you some properties to list for this. And when we say properties, this means it's always going to be true for this shape, and this is what makes this shape what it is. So we'll talk more about that later. But let's start with the first one. Parallelogram. Say it with me. Parallelogram. You might notice a word within that shape, parallel. So in a parallelogram, you're going to have 2 pairs of parallel sides. And if I go too fast in my note taking, make sure you pause so that you get down all these notes and don't miss any of the video while you're writing. So mathematicians, they love their notation. They have a special symbol that shows that sides are parallel, which is to put little arrows on them. So this side gets one arrow, and so does this side because they're parallel to each other. But then this side is parallel to this side. So we'll put two arrows on both of those. Okay. Now, the next quadrilateral we'll discuss is a rectangle. I bet you're pretty familiar with rectangles. They have 4 right angles. That is a special property of rectangles. And opposite sides are equal. And I'm going to use a shortcut, just draw an equal sign for equal. So we'll use our math notation here to show that this side equals this side, they're opposite, and then this side equals this side. When you draw 2 tick marks, it kind of looks like an equal sign even. So that's how mathematicians indicate that on the shape. The next special quadrilateral is a rhombus. And the only thing that needs to be true for a quadrilateral to be a rhombus is that it has 4 equal sides. So let's add our notation onto our picture. This side equals this side equals this side equals this side. For a rhombus, did I say anything about the angles? No, it doesn't matter. To make a rhombus, it has to be a quadrilateral with 4 equal sides. So would a rectangle be a rhombus? It would not, right? Because not all 4 sides are equal, only opposite sides are equal. Okay, we have 3 more special quadrilaterals. This one's probably the most famous quadrilateral, the square. And a square has 4 right angles, but it also has 4 equal sides. So that makes it a little different than a rectangle, right? Because this side equals this side equals this side equals this side. We'll add our math notation on there. So kind of interesting to think about. Is this square a rectangle? Well, we said for something to be a rectangle, it had to have 4 right angles. That's true. And we also said it had to have opposite sides are equal. Opposite sides, that equals that, and that equals that. So a square is a rectangle. But if we look at a rectangle, we said a square had to have 4 equal sides. So does a rectangle have 4 equal sides? No. So a rectangle is not always a square. So I always found that really interesting about geometry. A square is always a rectangle, but a rectangle is not always a square. I hope I blew your mind with that one. Next up is the trapezoid. Say that one, please, trapezoid. And the only thing that needs to be true of a quadrilateral for it to be labeled a trapezoid is it has at least 1 pair of parallel sides. And usually when I was growing up, we learned it as exactly 1 pair of parallel sides. Our textbook has said it a bit differently, so I guess mathematicians have changed their opinion over the years. But most commonly, you'll see trapezoids that kind of look like this one. And can you spot the parallel sides if you're looking at the shape? Right, the top and the bottom, those are parallel. These ones, they're not parallel. They would intersect if they kept on going, right? They would eventually intersect, but I'll erase that because I don't want to confuse my shape. So trapezoid has at least 1 pair of parallel sides. Sometimes you'll hear it as exactly 1 pair of parallel sides. And finally, our last famous quadrilateral is a kite. And a kite, we're going to learn some cool math vocabulary here. In a kite, adjacent sides are equal. So first we'll write that down, and then we'll talk about what adjacent means. Adjacent sides are equal. And adjacent just means next to. When sides are next to each other, they are adjacent. So if we look at this picture, these two are equal, and these two are equal. We'll add our math notation to this one too. These two are equal, and these two are equal. Adjacent sides are equal. Okay, now we're going to apply some of this vocabulary as we answer a few problems. So here's our word bank with all the quadrilaterals you just learned about. And we're going to look at the picture and decide based on the properties if this shape, which ones apply to each shape. So if we look at this first one, so if you're following along in your notes, make sure you write these down. If you are at home, make sure you're quizzing yourself as we go. So if we look at this first shape and we look back at all of our definitions that we just came up with for different types of shapes, what would we call this one? Let's go through one by one. Would we call it a rectangle? No, because it doesn't have opposite sides equal, or right angles for that matter. Would we call it a trapezoid? Well, let's see what a trapezoid said. A trapezoid said at least one pair of parallel sides. I don't see any parallel sides on here. They're all intersecting. Would it be a square? Square's got to have right angles. Not a square. Would it be a rhombus? What did a rhombus say? Let's look back at our definition. Rhombus had to have 4 equal sides. Not a rhombus. Would it be a kite? What do we know about kites? Adjacent sides are equal. Ding, ding, ding. I see that my adjacent sides are equal here, so I'm going to call that one a kite. Beautiful. Let's do the next one. And now I'm going to be tricky because in this, if it has more than one possible name, I want you to list all the names for this exercise. So when we look at this picture, what are all the names that could apply to this? Quiz yourself and play the video back when you're ready to reveal the answer. You probably thought right away that it was a square because all the sides are equal and it has 4 right angles. That is correct. But this could also technically be a rectangle, right? Because it has right angles and opposite sides are equal. Could it be a trapezoid if it says at least one pair of parallel sides? This has at least one pair of parallel sides. In fact, it has 2. So this one could even be a trapezoid. What about a rhombus had to have 4 equal sides? This is also a rhombus. And finally, a kite had to have adjacent sides equal. Oh my goodness. This is also a kite. This fits all of them by definition. I find that so fascinating. Now again, you're most commonly going to think of this as a square. And on the activity you do later, it'll ask you to just give one name. If I were just giving one name for this, I would definitely say a square. But technically, based on the properties, it's also any of these other names could work for it as well. Okay, we got a few more of these. I want you to pause the video and try these on your own. Then play back when you're ready to reveal the answer. Okay, let's go over a few key aspects and you can check your work. This first one, again, most commonly, you're going to recognize that that's a rectangle because it has 4 right angles and opposite sides are equal. That's how we would justify the fact that we could call this a rectangle. Technically, based on our definition of a trapezoid, at least one pair of parallel sides, technically it would count as that too, but most commonly you'll hear that is a rectangle. This one was a trapezoid because it had at least one pair of parallel sides. We can identify them right there. And then this last one, it might have been hard to tell in the picture. Hopefully you could see that all of these sides were equal, so that makes it a rhombus. But also, it could be named a kite. because a kite just had to have adjacent sides equal, and since all the sides are equal, the adjacent sides are equal. The ones next to each other are equal. So both those names would work for that. Now, the term parallelogram is a pretty big term to know because a lot of different quadrilaterals can be considered parallelograms, but some can't. Remember, we defined this back, if you check back in your notes, it says a parallelogram has to have two pairs of parallel sides. So if we're considering whether a shape is a parallelogram or not, we want to see does it have two pairs of parallel sides. So let's picture a rectangle. And does that have two pairs of parallel sides? Those are parallel? Those are parallel, right? They're never going to touch. So rectangle is a parallelogram. Okay, let's picture a trapezoid. And again, I know sometimes like a rectangle could be a trapezoid, but we'll picture the most traditional kind of trapezoid that you'd have right here. Is a trapezoid a parallelogram? Two pairs of parallel sides? It's only going to have one, so we'll put that as not a parallelogram. Now I want you to go ahead and try to sort square, rhombus, and kite and play back when you're ready to see the answer. Remembering this definition that a parallelogram has two pairs of parallel sides, you should have seen that a square and a rhombus are parallelograms, but a kite is not. And again, if you wanted to explain why a kite is not, you would say because it doesn't have two pairs of parallel sides. I can only see, actually I can see no pairs of parallel sides on my kite. So great job today. I know that was a lot of new vocabulary. Hopefully you have some fun distinguishing between the different quadrilaterals, and in the activity today you're going to get a chance to state what a shape is and give your evidence for that. So please remember to look back at all the great notes you took to help you with that activity.